For this next video, what I'd like to do is go through some calculations to determine how much fertilizer to add to meet crop demands. And we'll focus on both nitrogen and phosphorus. And this next portion of calculations focuses on both nitrogen and phosphorus, ultimately from the standpoint of degradation in the environment. So here's the calculation. This is also in your notes. A producer needs to apply 175 pounds of nitrogen and 65 pounds of P2O5 to their corn. Where does 175 and 65 come from? Those numbers come from producer taking a soil sample, shipping that soil sample off to a laboratory, having it analyzed for residual inorganic nitrogen present in the soil in the form of both nitrate and ammonium, oftentimes, organic matter content, expected crop yield, and what was grown previously on site, especially with a legume, to get nitrogen credit. Then a testing lab will go to a table, much like the tri-state fertilizer recommendations or whatever other recommendations are used within that state, and derive those two numbers. So, okay, the target application rate is 175 pounds of nitrogen per acre and 65 pounds of P2O5 per acre. It doesn't say per acre, but it's per acre. How much diammonium phosphate and urea are required to meet that recommendation? And we're going to apply diammonium phosphate and urea in pounds per acre. And we have to use both of these materials to meet the demands, because diammonium phosphate will meet the demands for P2O5, but the value of nitrogen in this fertilizer is too low, or the grade is too low to meet the entire demands for nitrogen. And thus we bring in another nitrogen-based fertilizer like urea. Okay, so how do we do this? So let's go through the calculation. So at the very top of this page, you see the text that came from the previous slide, right? The word problem, if you just write it out, it sometimes makes it a little bit simpler to see what you need to do in terms of the calculations, okay? So 175 pounds of nitrogen and 65 pounds of P2O5 are needed by the corn crop. And we're going to supply those needs using diammonium phosphate, you see the guarantee, and urea, and you see the guarantee. So this is what you're going to do logically. First, you should calculate how much P2O5 is needed, right? Why do we do this first? We do this first because with the diammonium phosphate, if we meet the demands of phosphorus for corn, when we apply a diammonium phosphate, we also apply a nitrogen. So the next step after the first step is to calculate how much nitrogen is added with the P2O5, with the diammonium phosphate. And then finally, what we need to do is simply determine how much extra nitrogen is needed via urea to make up the difference in the need for nitrogen fertilizer. So this is really a three-step process. So first, you want to determine how much P2O5 to add. And I wrote this down here. I'd like you to do the same thing in your notes if you're taking notes. Remember how to determine how much fertilizer to add based on the information that you learned in Unit 5B for determining how much fertilizer to add in solid form to meet a fertilizer rate, or in Unit 5B, it was a nitrogen rate. Okay, so the conversion from nitrogen rate to fertilizer rate. Remember how to do that? If not, you'll see it here. The same calculation for the nitrogen fertilizer rate, or conversion from N rate to fertilizer rate, is the same for phosphorus fertilizers. You simply divide the amount of fertilizer, in this case it's P2O5, needed by the percent P2O5 in the fertilizer, but you use the decimal form of the percent P2O5 in the fertilizer. So let me show you the math. This is what you do. You divide the amount that's needed, which is 65 pounds of P2O5 that was given in the word problem, and it's shown at the very top of this slide. And you divide that by the decimal form of the amount of P2O5 in the fertilizer itself. In this case, for diammonium phosphate, that's 0.46. And if you do the math, it tells you that you need 141 pounds of diammonium phosphate per acre. Okay, simple. I'm going to weigh up 141 pounds of diammonium phosphate, and I'm going to apply that over an acre. There we go. Oh, when we apply diammonium phosphate, we're also applying some nitrogen in the form of ammonium. Not that the form matters, but we're applying some nitrogen. So we need to take that into account. So the next step is to simply calculate how much nitrogen is added when you add 141 pounds of diammonium phosphate, which equals 65 pounds of P2O5, which is the requirement for this corn crop. So let's do the math. We added or are going to apply 141 pounds of diammonium phosphate, it's per acre, and it has 18% nitrogen in it. Where do we get that from? We get that from the fertilizer guarantee that you see at the very top of the slide. So what is 18% of 141? 18% of 141 is a number less than 141, logically, right? So if you ever have to do this on a test, try to think logically. 18% of 141 equals 25. Or when we apply 141 pounds of diammonium phosphate per acre, we're actually also applying 25 pounds of nitrogen per acre with that diammonium phosphate. Here's another way of looking at it. If you want to do the math a different way, 141 times 0.18. That equals 25 pounds of nitrogen per acre. Okay, so when we apply 141 pounds of diammonium phosphate, that is going to equal 65 pounds of P2O5 per acre, and that meets the crop P demand. We also apply, with diammonium phosphate, 25 pounds of nitrogen per acre. Does that meet the nitrogen demand of corn? Look up. The demand for corn in this scenario is 175 pounds of nitrogen, and it should say per acre. So we're short. We're actually short 150 pounds. So finally, what we need to do is determine how much nitrogen is needed with urea to make up that difference. Okay, so I just stated the math. Here I have it written down. The corn crop needs 175 pounds of nitrogen per acre, and 25 pounds of nitrogen per acre is applied with diammonium phosphate. So the difference is 150, or 150 pounds of nitrogen is needed from urea. Now, you've already done the calculation back in Unit 5B, and you've just done the calculation for P2O5 on the previous slide. So how much urea do we need to add to equal 150 pounds of nitrogen? Remember, you take the target application rate, which is 150 pounds of nitrogen per acre, and you divide that by the decimal form of the amount of, in this case, nitrogen in urea, which is 0.46. And that tells you that you need to add 325 pounds of urea per acre to meet the demand, or the overall demand, of nitrogen by corn. Okay, rather simple, I hope. And let's stop here, as this is the approach you would take for inorganic fertilizers. Next, in the next video, I want to show you the approach you would take for organic amendments.